There are a number of aspects or features of storage, especially cloud storage, that you could choose to take advantage of. Some of these are done automatically by a CSP, others may have to be implemented by the customer. Let's start with compression. This is a straight trade-off. You expend CPU time in order to reduce the size of the data on the storage. A feature that is related to compression is deduplication. This is almost entirely going to be on the part of the cloud service provider, where they go through and they look to see if there is duplicate data, either objects or blocks. And if that's the case, if there are multiple files that have mostly the same data, the provider could choose to reduce the copies of that data down to 1 and change the others to pointers, which also reduces the amount of space used. The third feature is replication. This could be done synchronously as the item's written. It could be done asynchronously afterward. But this allows you to have multiple copies of your data, regardless of whether it is block storage, file system storage, or object storage. Our next feature is thin provisioning, and I've mentioned this a couple of times. Thin provisioning means that you are only paying for the amount of data that is present in the storage. In this case, there may not even be a need to determine a maximum size. If you do need to determine a maximum size, that's where thick provisioning comes into play. This is where you provision more storage than you actually need, but when you do that, while you might get better performance, you are also paying for that amount of provisioned storage rather than the amount used. And finally, we have a concept called hyperconverged storage. Hyperconverged can be used in other contexts, but when we apply it to storage, it means that we are combining, in a virtual machine perspective, we're combining the virtual CPU, the memory, and the storage into a single resource. The next term that I'd like to define is SDS, Software Defined Storage. This is where you actually separate out the control plane from the data plane. The control plane is what you would use to provision storage, back it up, or delete it. The data plane is what you use to access the actual data on the storage, to add data or remove data or modify it. This means that the hardware becomes abstracted from the client entirely. NAS, SAN, and traditional storage can all use software-defined storage. It also allows for policy-based management and the ability to implement permissions against the control plane that are different from the data plane.